In this video, we will talk about some acid-base equilibrium titrations. The first type of titration that we are going to consider is between a strong acid and a strong base, meaning that they are going to dissociate completely in water. And therefore, if we know the concentration of HCl, then we know the concentration of H plus and of Cl minus, and therefore if we want to calculate the pH, remember the pH is equal to the negative log of the concentration of the acid, so negative log of 0.1 molar, and we get that the pH is equal to 1. If we write out the net ionic equation between HCl, so HCl plus NaOH, if we do the formula first, we get NaCl plus water, liquid, aqueous, aqueous, aqueous. So if we do the complete ionic first, we get H plus aqueous plus Cl minus aqueous plus Na plus aqueous plus OH minus aqueous goes to Na plus aqueous plus Cl minus aqueous plus water. And then our net ionic, I'm going to cancel out the spectator ions. So we have Cl, Cl, H+, and we get H plus aqueous plus OH minus aqueous goes to H2O liquid. So again, this is our driving force for the reaction. The reason that the reaction occurs is because it forms water, which is a liquid in a different phase. At the beginning of the titration, we are only going to have the acid in the Erlenmeyer flask. So at the beginning of the titration, you have the Erlenmeyer flask, you have your acid in it, and you have not added any of your NaOH yet. So we haven't added NaOH, so the volume of NaOH is 0. And so if we have a 0.1 molar acid in the Erlenmeyer flask, that means that our initial pH is going to equal 1, which we calculated on the previous slide. So I'm going to add that to my graph paper. So 1 is right about here. So I'm going to put a little dot for the pH with a 0 volume of NaOH. Okay, so then let's say again, we're doing our titration, and initially we have 0.1 molar of the acid in the Erlenmeyer flask. And it says that we have 20 milliliters of this 0.1 molar solution. And then it says that from the burette, we are going to add a volume of 5 milliliters of the NaOH. So let's visualize what this looks like. So originally we have, let's say, 4 molecules of HCl. So I'm going to draw that out. Again, HCl is a strong acid. It's going to dissociate in water to H plus and Cl minus, so completely dissociate. So we get H plus and Cl minus floating around in solution. Okay, we have 4 of those, and we have 1 formula unit of NaOH. So I'm going to just draw 1 formula unit of NaOH. So that dissociates. And then I'm going to mix these two solutions together. And if I mix those two solutions together, then the OH minus is going to react with the H plus, and I am going to make 1 molecule of water. But the rest of it is still floating around in solution. So I still have H plus aqueous, Cl minus aqueous, H plus aqueous, Cl minus aqueous, H plus aqueous, Cl minus aqueous, and I also have the Na plus. So we have Na plus aqueous and another Cl minus aqueous. So those are just ions that are spectators just floating around solution. And I have excess of the H plus ion, meaning that I still have an acidic solution. So the solution is still acidic. I have only had 1 OH minus to react with the water, and I needed to have 1, 2, 3, 4 OH minuses to get to the equilibrium point. Okay, so at this stage, let's look at the major species. So if we look at the molarities, if we compare the NaOH, we had 0.005 liters. And we had a concentration of 0.1, so 1 liter, 0.1 moles. And that is going to give us 5 times 10 to the negative 4 moles of Na plus and OH minus. Okay, because they're dissociating completely. And then to start out with, I have we had 0.020 liters of HCl and a concentration of 0.1 moles per liter. And so we had 0.002 moles of H plus and Cl minus. Okay. So we're going to plug that in to our equation. So before the reaction, we originally had 0.002 moles of H plus, which we calculated in the previous slide. And we had 5 times 10 to the negative 4 moles of OH minus. We saw that the OH minus reacted completely. So when we were changing, this was minus X, this was minus X. So we saw OH minus reacted completely. So we know that this needs to equal 0. So we know that 5 times 10 to the negative 4 minus X needs to equal 0. And therefore, this is the limiting reactant. It's what is going to run out. So we can say that X is approximately 5 times 10 to the negative 4. So we are going, so this is supposed to be 0.002 minus X. So we can change that to 0.002 minus 5 times 10 to the negative 4, and we get that the concentration of H plus in the solution after the reaction is approximately 0.0015 moles. Okay, so if we know that, then the final concentration, so the concentration of H plus is going to be moles per liter. So we have 0.0015 moles of H plus, and the total volume is going to be the 5 milliliters of NaOH originally added plus the 20 milliliters of HCl. So the total volume is 25 milliliters or 0.025 liters. And I get a concentration of 0.06 molar. So again, I calculate the pH. So pH is equal to negative log of the concentration of the acid. And what I'm going to get then as the pH is going to be 1.22. So we're going to plug this onto our graph. So we so far found that with 0 volume, we had 1, the pH of 1, and at a volume we just calculated of 5 milliliters of NaOH, we saw that the pH was equal to 1.22. So 5 is going to be 1.22, so we're just going to go up a little bit more and draw it on our graph. Okay, so the next step of the titration, so again we have the NaOH in our burette and we had the acid in the Erlenmeyer flask, and if we keep adding NaOH, now we have a volume up to 15 milliliters, and we have a total volume of 20 milliliters of the acid. So let's draw this again. So realize that the acid volume isn't changing. The only thing that is changing during this titration is the volume of the NaOH. So we started with 0 NaOH and we had a pH of 1. We added 5 milliliters of the NaOH and we had a pH of 1.22. And now we're adding 15 milliliters of NaOH. And we're going to see how that changes the pH. But the volume of the acid concentration is constant. It's the NaOH that we are changing. So let's do a visual of this again. So we have 4 molecules of HCl. So we're going to draw that 4 times. And it's a strong acid, so it's going to dissociate completely into its ions. Okay, and then we have 3 formula unit of NaOH. So again, that's a strong base, so it is going to dissociate completely into its ions. Okay, and what is going to happen is these 3 OH can react with 3 of the H+, and we are going to form 3 water molecules. And then draw whatever is still remaining. So we still have an H+, Cl-, and we have 3 Na+, and still Cl-. So we still have excess of H+, so this is still going to be an acidic solution. Okay, so now we need to look at the moles of the major species. So the ions. So we have a volume of 15 milliliters or 0.0150 liters of NaOH and a concentration of 0.1 moles per liter. And so if we calculate that, we have 0.0015 moles of the Na+ and OH- ions. And then if we calculate the HCl, we have 0.0200 liters. And we have a concentration of 0.1 moles per liter. And so we have 0.002 moles of H plus and Cl minus. So we can see that that is the same amount of moles that we had in the previous equation. Okay, so if we use the moles before the reaction, so we had 0.002 moles, and we have 0.0015 moles of OH minus, the change minus X, we know that all of the OH minus was consumed, so 0.0015 minus X has to equal 0, and so this is the limiting reactant. So OH is the limiting reactant. And so we can say X is going to be equal to 0.0015. So if we plug, let me write the original equation, minus X. And if we plug that in, 0.002 minus 0.0015, then we get that we have 5 times 10 to the negative 4 moles of H plus. So now we can calculate the final pH of the solution once we've mixed both of these reactants together. And so H plus is going to be moles over liter. So we calculated that H plus is 5 times 10 to the negative 4 moles. If we add up the volume, so we had 15 milliliters of NaOH and we had 20 milliliters of HCl, our final volume is 35 milliliters or 0.035 liters. And so our concentration of H plus after these have been mixed is 0.014 molar. So if we calculate the pH, that is going to be equal to the negative log of the concentration of the acid in solution. And so that is going to equal 1.85. And then you can put that on the graph paper on page 4 of the worksheet. And I am going to let you calculate the remainder of the worksheet on your own. Please let me know if you have any questions. I'd be happy to answer them.